section 14.5 is solving equations now, so you'll notice there's an equal sign here. So what we want to do is we now want to solve for x. But if equations were bad enough, what happens when we throw in all these fractions? Who wants to do this with fractions? Not I, right? So the whole idea here is we have a system where if we multiply by the LCD, we actually can get rid of the fractions. So that's going to be the first thing, is we're going to try to eliminate these denominators so we don't actually have to do math with the fractions. And then once we eliminate the denominators, we'll be able to solve the equations like you guys did in Math 112, elementary algebra, okay? So it is good practice because we have to think about an LCD, but we're not actually going to convert these to new things and do math with them. So let's start with this first one, guys. What do you notice? What would the common denominator be between 2, 3, and 6? Well, what does 2 need? A 2, right? What does the denominator 3 need? A 3. What does 6 need? A 6, but don't 2 and 3 multiply to be 6? Right? So guess what our LCD is? 6, all right? So instead of turning that into a fraction over 6 plus a fraction over 6 equals 1/6 and doing the math for fractions, what we're going to do is we're going to take the left side times 6 and the right times 6. We're going to take everything times 6, okay? So this will be 6 times x over 2 plus 6 times 8 over 3 equals 6 times 1 over 6. So all I did, guys, if you notice, is I just took each of our little fractions and I multiplied by 6. And if we do it correctly, by multiplying everything by 6, we are going to eliminate the denominator. So we're not going to have to do any math with fractions. All right. So when I multiply by 6, you can think of it as 6 over 1, right? So do you agree that this 6 on top cancels out with that 2 on the bottom? Yeah, what will happen? What will happen to the 2? He'll go away, and what will the 6 change to? 4. A 3, right? Because we're dividing, okay? So 6 divided by 2 is 3. All right, we'll keep him there. We'll go on to the next guy. Do you guys agree that 3 goes into 6? Yep, so what happens to the 3? He disappears, and what's the 6 going to change to? A 2. And then last but not least, over here, do you agree that 6 goes into 6? So what's going to happen there? That will change to a 1. So since we multiplied by the LCD, every denominator went into that LCD. So we were able to eliminate it. All right, at this point, we just multiply what's left, all right? So here, what do we have? We have a 3 times an x, or a 3x, right? We have a 2 times an 8, or 16. And we have a 1 times a 1, or 1. Can you guys solve that equation? It looks a lot better than that equation up there, right? So what we've done is we've reduced it to a linear equation where it's, let's move the constant over and divide by the coefficient, right? So we'll subtract 16 over, and we'll be left with 3x equals what? Negative 15 there? And then what's our last move, guys? Divide by 3. Bless you. So x is negative 5. What's different about this section versus like chapter 13 when we did equations is we have to check our solutions. And what does that mean? We don't necessarily have to plug it back in and make sure the left equals the right, but that's what we did. We found that x, so if we plug it in, negative 5/2 plus 8/3, if you hit equal, will equal 1/6. That's the whole idea. But what we want to check for is to make sure it's in the domain. So look at this number 3. It says check the solution. Make sure x is in domain. Okay, so say you do all this and you put this into the MyMathLab and it says it's wrong. It might not be wrong, it just might not be in the domain. Okay? But look at our denominators. Our denominators are 2, 3, and 6. Are they ever anything other than 2, 3, and 6? No, there's no x there. So this would be a domain of negative infinity to positive infinity, meaning x can be anything. And so negative 5 is okay. Guys, the next one's very, very similar. For our LCD, what does our first denominator need? A 2. What does our second denominator need? A 3 and a 3. What does 18 need? Well, 18 would split up as 2 times 9. But what's 9 split up as? 3 times 3. 18, guys, is our LCD. Does that mean we're going to change each of these new denominators or old denominators into this new denominator of 18? No. It means we're going to take each rational and multiply it by 18 so we can get rid of the denominator, okay? So this is 18 times x minus 4 over 2 minus 18 times x minus 3 over 9 equals 18 times 5 over 18. It just so happens that the far right one ends up being our LCD on both the first two things, but that's not always the case. Alright, so once we do this, we're going to go back through and say, okay, how does this knock out the denominators, alright? So, how many times does 2 go into 18? 9 times, so the 2 will disappear and the 18 will turn to a 9. How many times does 9 go into 18? 2, so the 9 will disappear and that will change to a 2. And then how many times does 18 go into 18? 1. So what remains will be 9 times the quantity x minus 4 minus 2 times the quantity x minus 3 equals 1 times 5 or 5. Do you guys see what I did there? I just said what was left. Who was left on the outside of the parentheses? The 9. Who was left on the inside? The x minus 4. Who was left on the outside of the parentheses? The minus 2, and then x minus 3. And again, it's an equation that hopefully we feel comfortable solving. What's the next move we need to do before we start isolating things? Get rid of those parentheses, right? So we're going to distribute the 9 in here and here. So what do we have? 9x minus 36. And then take the negative with you guys. So that will be a minus 2x plus 6. Because the negative 2 times the negative 3 will give you a positive 6 equals 5. Gather like terms on the left before you start moving things around. So what's 9x subtract 2x? 7x, right? What's a negative 36 plus 6? You got it, negative 30 equals 5. At that point, what are we going to do? Add the 30 over and then divide by 5. So 7x equals 35 or x equals 5. Is that what you guys got when you did that? So you ask yourself, is it okay for x to be 5? Well, go back to your original problem. Your original problem had a denominator of 2, 9, and 18. Will those denominators be anything other than 2, 9, and 18? No, there's no variables there. There's no way to make them 0. Meaning if this was a domain problem, you guys would say, oh, negative infinity to positive infinity. Every x is okay. If every x is okay, that means positive 5 is okay. Woohoo! Alright, let's go to this next guy. What do you guys notice about this one? What's the only denominator? X, right? Isn't this over 1, and this is over 1, and this is over 1? So if your only denominator is x, guess what your LCD is? X. Yeah, he's the only guy we need to get rid of, okay? So what we're going to do, yeah, you might want to get a separate piece of paper. No, it's okay. What we're going to do is we're going to multiply 3, negative 6 over x, x, and 8 all by x, okay? So this is going to be x over 3 over 1 minus x over 6 over x equals x times x over 1 plus x times 8 over 1. Well, we don't really need over 1, but I'm just showing you that, you know, they're going to not really be there. Okay? So 1 goes into x amount of times, so you're left with x times 3 or 3x. X goes into x perfectly. Those are kind of hard to cross out, so you're just going to be left with minus 6. Over here, the 1 is not really necessary, but what's x times x? Not 2x, but x squared, right? We'll add those exponents, x squared. And then at the end, we'll have 8x. So this is something new. We got rid of our denominators, but it's not an equation that looks like example 1 or 2. It's now a quadratic. And so it's good practice for chapter 13. Whenever we have a quadratic equation, what do we want to do? Get everything to one side equal to 0, and use the AC method, okay? I like to keep my x squared positive, so I'm going to move everything to the right. So I'm going to have 0 equals x squared. But when I move the 3x over, since he's positive, I'm going to subtract him, so that will give me a positive 5x. And when I move the 6 over, he's negative, so I'm going to add him, so I have plus 6. So our remaining trinomial should be x squared plus 5x plus 6, all right? So again, kind of some wand waving here, guys. What you would do is you use the AC method. What are factors of 6? That adds to 5, 2, and 3. Rewrite it, do factor by grouping, okay? And we would get 0 equals x plus 2 and x plus 3. And do you remember what we do once we factor them to solve? How do we solve for x at that point? You set each of them equal to 0, right? Like, how can, like, I know this looks weird, but if x was 1, this is 3, this is 4, right? How can one number times another number equal 0? One number or the other number have to be 0, right? So we set them equal to 0, but in this case, it's just a matter of flip-flopping our signs, right? So x equals -2 and x equals -3. Are both of those okay? Well, let's go back to our original. What was our only denominator? X, and what don't we want our denominator to be? 0. So in this case, our domain would be all real numbers except for 0. But did we get 0 as our answers? No. So -2 and -3 are okay. So we actually found 2 answers that work, that when you plug them in here and do the math to get the left equal to right. And that one's not too hard to check. Like if you plug -2 in there, 6 divided by -2 is -3. 3 minus the -3 is a 6 over there. So this side's 6. And you plug -2 over there, what's -2 plus 8? 6. So 6 equals 6. So kind of keep that in mind. That's what we're doing. We're trying to find those x's that make the left equal the right. All right, so this is kind of practice with what we were doing on that review worksheet, or what's due tonight on homework, right? Finding that LCD. So what's the first thing we're going to have to do? We're going to have to factor him, okay? What are factors of -30 that add up to 1? Well, you pray that it's these two, right? So that you don't have 18 different things, and it is, all right? This is x plus 6, x minus 5, if you were to use the AC method. X plus 6, x minus 5. All right? So if you were going to find an LCD, you start with the first denominator. What do we need? X plus 6, x minus 5. And you move on to the second, what's he need? An x minus 5. And you move on to the third, what's he need? An x plus 6. So do you guys agree that factored form of x plus 6, x minus 5 would be your LCD, okay? So for tonight's homework, it's adding, you would make everything equivalent fractions with over x plus 6 over x minus 5, okay? And you would do all the math. But that's not what we want to do. We want to use that to start slashing down the denominators, okay? So this gets kind of long, but it's how I do it. I take my LCD, so x plus 6, x minus 5, times my original fraction, 4 over x plus 6, x minus 5. Okay? So notice that's just this guy in factored form. So that way I can see that they cancel out completely. All right? I'm going to see my LCD again, x plus 6 times x minus 5, and multiply by the next denominator, or excuse me, the next rational, 2 over x minus 5. And last but not least, this equals x plus 6 times x minus 5, all times 1 over x plus 6. I'm kind of creeping into the next one. I'm sorry about that. I should spread out my notes. So do you guys see that everything that's in the big parentheses is our original equation? 4 over its denominator, 2 over its denominator, 1 over its denominator. But why am I doing this? Because our LCD should start knocking out the denominators, all right? So let's start with the first one. The first one was our LCD, so guess what cancels out completely? The denominator. What's that leave us with, guys? Just a 4. Over on the second one, what cancels out? The x minus 5, so that will leave us with 2 times the quantity x plus 6. So x plus 6 is going to stay in those parentheses, all right? And so we're going to eventually distribute that 2 through there. And then the next one, what cancels out? the x plus 6, and I'm going to write it as 1 times x minus 5. Do you ever really put a coefficient of 1 like that in front? No, but the reason why I do that is I want you to remember that whatever's there, multiply it by the x minus 5, right? So if that was a 2, that would be 2 times x minus 5. Again, guys, at this point, it's not too bad to solve. What we're going to do is we're going to distribute to get rid of our parentheses and gather like terms. So that 4 is going to hang out as we distribute the 2. So we have 4 plus 2x plus 16, I can't do multiplication, 12, right? 2 times 6 is 12. And then if this was anything other than 1, you would distribute it, but 1 times x is just x, and 1 times negative 5 is just negative 5. I like to get my two sides, my left and right side, simplified before I start moving things over, okay? So on the left, what can I combine? What are like terms over there? The 4 and 12. So that's 2x plus 16 equals x minus 5. So I just got the 4 and 12 and added them together. And then I'm going to move my x over to the left by subtracting it and add my 16 to the right, or subtract my 16, right? So we can subtract him over, and we will subtract him over, okay? So what's a 2x take away an x, what's negative 5 take away negative 16? Negative 21. So I just moved them over at the same time. All right, go back to your denominator. What are their two yucky spots? Our two no-no spots are negative 6 and positive 5, okay? So you would write in a domain, all x's are okay except for negative 6 and 5. But notice here, this is neither one, so this answer is okay. We can plug negative 21 in and do the math because it's in our denominator, or in our domain. Negative 6 and 5 are not in our domain, though, so we'd have to be careful. I know there's not a whole lot of room over here on the right, so hopefully we can squeeze it in. Notice on the right we have just two denominators, but they match, and so that is our LCD. Our LCD is x minus 4. Our LCD is x minus 4. So I'm going to take x minus 4 times 2x over x minus 4 equals x minus 4 times 8 over x minus 4 plus x minus 4 times 1. I'm really squeezing it in there, I'm sorry. And you guys, you might get comfy where you might start throwing it up into the actual original equation, that's fine. Like you might do, or you might already see what's happening. Like when you multiply this by x minus 4, you know that 2x is going to be the only thing left. That's fine. Like if you can kind of skip steps. Alright, so since these first two expressions had x minus 4 as the denominators, that cancels and just leaves you with the numerators. So we're going to have 2x equals 8 over there, is that okay? And then if this was anything other than a 1, we would distribute it, but that just leaves us with x minus 4. Is that okay? I know it's getting kind of crowded. So 2x was already over x minus 4, so that denominator cancels out. 8 was already over x minus 4, so that denominator cancels out. And then 1 wasn't over anything, so we did have to multiply 1 times x to get x, and 1 times negative 4 to get negative 4. Again, before I start moving things around, I like to clean up like that right side. What can we combine on the right side? Yeah, so basically 8 minus 4, right? So we'll have 2x equals x and then plus 4. Does that look okay? Because 8 minus 4 is 4. I'm going to subtract the x over, and you'll get x equals 4. But before you circle it, or before you put it into my math lab, what do we have to ask ourselves? We have to ask ourselves, is that in the domain? What would happen if you put 4 up here into your denominator? You get 0. Is that good? No. That's the one whole, right? Like in our denominator, we say all x's except for x equals 4. So what do we need to write? No solution. And let's make a note of it. Like this is not in domain. And then you're like, I don't know what that means. Okay, let's write a little bit more. Let's say makes denominator 0. So that's something to kind of just check. Like, if you put it into my math lab and you get a red X, before you like say, oh crap, and do it all over again, just double check the domain, okay? Because that might just be your issue. So in my math lab, every time you go to do a problem, it's going to have two things you can click. Click the solution for x equals, or the second one is no solution, okay? So no solution, you don't necessarily have to type, you just have to choose it. All right, this one's kind of interesting. Here what we have is two denominators, but they don't share anything, okay? I know that one has an x in it, but it's not x times something, it's x plus something, okay? So maybe x is 3, well that means that denominator is a 3 and that denominator is a 7. They don't share anything, okay? So the LCD ends up just being the product of the two, x times x plus 4. And don't distribute, leave it factored out, that way you can see what cancels, all right? So whenever you find your domain, or excuse me, your LCD, take this side, x times x plus 4, times the original fraction, 15 over x plus 4, equals the LCD, x times x plus 4, times the original fraction, x minus 4 over x. Okay? So again, my big parentheses are what was there originally, 15 over x plus 4, and x minus 4 over x. But then we should be able to knock out these denominators when we go back, okay? So when you go back to the first fraction, its denominator was x plus 4, so that's going to knock out the x plus 4, which will leave us with what? 15x, perfect. Over here, its denominator was x, and it'll knock out the x, so that will leave us with x plus 4 times x minus 4. That's interesting. Okay. So you guys have been doing really well where once we knock out the denominators, you know what you need to do next. We need to get rid of those parentheses. But here, this is the issue of foiling to get rid of the parentheses, okay? So it's not just like, oh, distribute the 3. We got to distribute the x to both things and the 4 to both things, all right? So this 15x will hang out as we foil this, all right? So x times x is x squared. X times negative 4 is a negative 4x. 4 times x is a positive 4x. And 4 times negative 4 is negative 16. When we do that, guys, you'll notice this middle two terms, negative 4x and positive 4x, cancel, and that should make sense. That was a difference of two squares, right? How do you factor x squared minus 16? You factor it to x plus 4, x minus 4. All right, so this is kind of like example number 3 that we had to do. Is once we got rid of our parentheses and everything, a quadratic arose, okay? And when a quadratic comes into light, we got to get everything to one side equal to 0. Since most of the stuff's on the right, I'm going to go ahead and move this 15x over. I'm going to move him by subtracting because he's positive. And when I move him over, I'm going to put him right in the middle because he's our x term, right? Because we have our x squared and we have our constant, we want our x right in the middle. So this will be 0 equals x squared minus 15x minus 16. So how would we go about solving that? We would have to use the AC method. So again, some wand waving. What are factors of negative 16 that add up to negative 15? Negative 16, positive 1. Rewrite your middle terms, factor by grouping. This factors to x minus 16, x plus 1. So at that point, kind of like Anna said earlier, is that we would set each of those equal to 0 and solve. So what are our two potential answers for x? 16 and negative 1. Are both of those okay? Are both of those in our domain? We go to our LCD. What would make our LCD 0? 0 and negative 4, right? And this is neither 1, okay? So this is okay. We have our solutions. 16 and negative 1 both make the left side equal the right side, which is pretty interesting that we can have two answers there. All right, let's see if I can squeeze in this last one before the recording cancels on me. All right, before we find our LCD, we got to factor everything. X plus 3 is not going to factor, but what can we take out of 4x plus 12? A 4. And when you do that, what are you left with? X plus 3. Is that all right? And then LCD here, guys. Let's go ahead and start. Do you guys agree that we need an X plus 3 as our LCD? Or in our LCD, leave a little bit of room in front of it, okay? So I'm going to put x plus 3 here with a little bit of room. But we also need a 4 for this denominator, and we need an 8 for that denominator. But what number does both 4 and 8 go into? Well, 2 goes into both of them, but what numbers do they go into?
What was it?
What number do both 4 and 8 go into?
1, 2, 4.
This is what's hard. You guys are thinking of factors, not common multiples, right? Right? Because 8 doesn't go into 2, 8 doesn't go into 4, but does 8 go into 8?
Yeah.
Does 4 go into 8?
Yeah.
So 8 is your answer there. Another one would be 16, right? 8 goes into 16, 4 goes into...
It can be bigger than...
It can be bigger. I usually go with the smallest, though, just so it doesn't get too big. Okay? So kind of keep in mind, that's what's hard. We're so used to factoring and finding the common factor between 4 and 8, but LCD is actually the common multiple. It's the numbers that 4 and 8 go into. All right, so we're going to take this 8 times x plus 3. I'm going to start way over here and multiply by my first fraction, 2 over x plus 3, equals 8 times x plus 3, and multiply by my second fraction, 5 over 4 times x plus 3. I'm going to leave him in his factored form there. I'm not going to write 4x plus 12 anymore. Minus 8 times x plus 3 times my last fraction, 3 over 8. So again, kind of notice how I did it. My LCD is always out in front, and my fraction is always right behind it. LCD, my fraction in factored form. LCD, my fraction in factored form. And then you can just start flashing stuff, all right? So looking at this first one, x plus 3 cancels out, so you're just left with 8 times 2, or 16. When you go to the next one, the x plus 3's cancel out, and don't you agree that the 4 reduces the 8 a bit, right? What will the 4 turn into? A 1, but what will the 8 change to? A 2. So you're left with 2 times 5, or 10. And then over here, just the 8 cancels out, so let's write that as minus 3 times x plus 3. Always write that coefficient in front so you do the distributing properly. So the x plus 3 is canceled out with the first one. That left us with 8 times 2, or 16. The x plus 3 is canceled out with the second one, and the 4 also reduced the 8 to a 2, so we're left with 2 times 5, or 10 down here. And then here, only the 8's canceled, so we're left with an x plus 3 and a 3, so I just bopped them in front there. So when we go to distribute, the key thing, guys, is that negative's going to go with them, all right? So make sure you change both of those signs. So this will be 16 equals 10 minus 3x minus 9. 16 equals 10 minus 3x minus 9. Gather like terms, so on the right you can do 10 minus 9, so you just have 16 equals, what's that going to be, negative 3x plus 1. And it doesn't really matter which way you go, but since my x is already all together on one side, I'm just going to subtract the 1 over to get 15 equals negative 3x. So what's your last move? To divide by a negative 3, but what's 15 divided by a negative 3? Negative 5. And before I circle it, I just go up to my LCD. Is it in my my domain? Yes. What's the only thing that would make this LCD a 0 is a negative 3. So a negative 5 is fine. I mean, we're getting kind of close, but that's fine.